Hello everybody and welcome back to another lecture video. This week we are on week 14 and we're going to be starting a new module on conveyance systems. This is going to be the final module that we cover in this course. Your reading for this week is going to be the Bengali textbook, chapter 19, and this is from pages 376 to 389. So the chapter itself is actually pretty short, so it shouldn't be too bad. And this lecture should not take too long, hopefully. All right, so let's go ahead and get started. So as an introduction, conveyance systems include both horizontal transportation systems, as in moving walks or horizontal conveyors, and also vertical transportation systems, so things like elevators, escalators, and dumbwaiters. Vertical transportation is a major consideration for interior designers and architects, and the reason for this is because the entire vertical transportation system is going to have a major impact on the shape of the building, the layout of the building's service core, and also the lobby design. Vertical transportation systems actually account for 10 to 15% of the construction budget for tall buildings. So a lot of thought goes into these systems and how they're incorporated into new buildings, and they take up a relatively significant chunk of the budget usually. Just like every other building system, the design and installation of conveyance systems are heavily regulated by building codes. All right, so you should be pretty used to that by now, especially in this course. Pretty much everything that we've talked about has some sort of a building code regulation tied to it. The installation requirements for vertical transportation systems are governed by the American Society of Mechanical Engineers, or ASME, and the specific standard that is related to elevators, escalators, all that, is the standard A17.1 safety code for elevators and escalators. The codes typically require elevators to be connected to emergency power so that elevators can still operate in the event of a power outage. So obviously, if you were on an elevator within a building and you're using it and the power goes out, you don't want to be stuck in there. I know that's probably everybody's greatest fear when they're in an elevator, that they're going to get trapped into it. But you can rest assured, because the codes require elevators to be hooked up to some form of emergency power, so that in that event of a power outage, you have a way for the elevator to continue working so that you can actually go to the next floor and get off safely so that you're not stuck in it. All right. Elevators provide a convenient and accessible means of vertical transportation in buildings. They also make high-rise buildings practical. So if we're talking about high-rise buildings, skyscrapers, obviously those would not really be possible or practical if we didn't have some kind of vertical transportation system other than stairs, right? You don't want to really climb 80 flights of stairs to get to the top floor. So since we have these sorts of systems, we can make taller and taller buildings, and they become more and more practical and realistic. Okay. So there's going to be 4 basic types of elevators. The first one is going to be the elevator that you are most familiar with in everyday life, and that is just a regular passenger elevator. And these are elevators that are used to transport people. We also have service elevators, and these are elevators that are used by staff and building personnel. So as you can see in this picture here, these are a little bit larger. They have a more specialized use case. They might not just be used only to transport people. You may also have some goods on there as well, and they also just look a little bit different. The third type of elevator is going to be a freight elevator. So these are very large elevators that are specifically made to move goods. So in this picture here, you can see a very old vintage version of a freight elevator. When I worked at my firm up in Cleveland, Vocon, we actually had one of these in our building. So the building that they have for their firm was a remodeled old automotive garage or It might have been a dealership, very old, from the early 1900s, late 1800s. And they actually had a freight elevator in the back of the building that was originally used to move cars up and down from one floor of the building to the other. So it actually looked just like this. But these types of elevators, again, mainly just used for moving heavy goods from one level to the next. And then the last one is going to be a residential elevator. So these are used inside homes, and these are typically only used for accessibility reasons. So if you have somebody who's disabled and they could afford to have an elevator put in their home, that would be a use case for a residential elevator. Here you can see is just a basic example of one in a modern house. All right, so next we'll talk a little bit about elevator design. So the details of elevator installations are usually handled by architects, engineers, and elevator consultants. So the layout and configuration of elevators within the building usually gets very technical, just like a lot of the other things we've talked about. And a lot of that is going to be handled by engineers, so we won't have to worry as much about it. But the thing that we will have to worry about as an interior designer is how these systems affect our space planning. All right. So interior designers are not usually responsible for elevator placement and layout, but they often need to work around elevator placements when space planning. Okay, so that's sort of an impact that it will have on our jobs. Interior designers often have a role in the design of elevator lobbies, and these have a great impact on the comfort of building occupants and visitors, since people often congregate in them to wait for elevators. Okay, so when we're designing these spaces where people are going to be waiting for elevators, we want to make sure that they are spacious enough so that people are comfortable. If you have a lot of people gathering within them, everybody has to have plenty of room. And also you need to make sure that they are complementary to the design of the rest of the building, and that they're just warm, inviting spaces and not afterthoughts. Because, you know, if people are using these spaces regularly and they're spending significant amounts of their day in them waiting for elevators, you want to make sure that they are comfortable to be in, just like everywhere else in the building, and that they're just not some afterthought that's sort of tacked on or not really fleshed out. Elevator lobbies and hallways that approach them are designed to be large enough for the peak load of passengers, with 5 square feet of floor space allotted to each person waiting. Okay, so that's a pretty big amount of space, but it's a consideration that you need to have whenever you're designing these spaces to be comfortable. All right, so elevator accessibility. Elevators are required to meet the minimum accessibility standards defined in the 2010 ADA Standards for Accessible Design. So we've talked about ADA before. You should have covered this in some of your prior classes as well, but the ADA standards are going to have a significant implication on the design and layout of elevator and other types of conveyance systems. The ADA standards define minimum clearance for elevator cabs, as well as requirements for elevator lobby signals and buttons. Elevator lobbies are required to be equipped with audible and visual signals that alert occupants when elevator changes floors or if it arrives at a particular floor. So this is useful for people who might have hearing or visual impairments, so that they can tell when the elevator has arrived, right? You get that audible ding and you know that the elevator is there and they're ready to get on. Also, the lights that they have on the wall that indicate if the elevator is moving up and down or what floor it's on, those could be useful for people who are deaf, who cannot hear that audible signal. Hall signals must be located at a minimum of 72 inches from the floor. So the hall signal is just what I said. It's that visual light indicator that is mounted on the wall that will show where the elevator is, what floor it's on, and if it's going up and down. And then the call buttons, these are the actual buttons that you press to call the elevator and tell it if you want to go up or down. These must be placed 42 inches from the floor, and they must include Braille. Okay, and that's all based on the 2010 ADA Standards for Accessible Design. Down here you can see a couple of schematics that were pulled from that ADA standards. And these just define the minimum clearances for elevator cabs, okay? So if we have an elevator cab with a center door, these are going to be your minimum interior dimensions. And then if we have one that is an off-center door, it's going to have slightly different dimensions. So this one's going to be a little bit smaller. So this is just sort of to recap what I just mentioned on the last slide, but here we have our call buttons, okay? Those are the buttons that you're pushing to call the elevator, and the center of the faceplate of the call buttons, that has to be exactly 42 inches above the floor. Over here is going to be our hall lantern. So these are our lights that are indicating if the elevator is moving up or down. You want the center of those to be a minimum of 72 inches above the floor level. All right. And then here we have an indicator that's telling us what floor we're currently on, and that is going to need to be 60 inches above the door. Here are some of the basic parts of an elevator. All right, so the main shaft that we have that the elevator cab rides up and down in between levels of the building, that's known as our hoistway, all right? Or you could also call it the shaft, but the technical term is a hoistway. The car or cab is the thing that you're actually getting into and you're moving up and down within. And then we have things like guide rails, which are used to guide the elevator as it moves vertically so that it doesn't get off center. We also have our hoisting cables. These are the actual cables that are being pulled by the motor that are actually going to hoist the elevator up and down with through the hoistway. We have a counterweight, which is used to counterbalance the elevator. And then up here at the very top is what's known as the penthouse. So this is going to be on the roof of the building, and it's just an enclosed space on the roof, and this houses the elevator machine. Okay, so right here's the elevator machine, and this is just basically a big motor that drives the entire thing. So it has some kind of like a winch system on it, and this is going to be pulling on that cable and making the elevator go up and down. All right. Elevator cabs are typically pre-engineered, pre-manufactured components, and the interior finishes of the cabs are usually determined by the manufacturer. But on higher-end projects, custom cab interiors may be specified. In these cases, interior designers may be responsible for determining the cab's interior finishes and any custom architectural details such as cove lighting. All right, so if you find yourself in some sort of a hospitality type design job where you're dealing with some of these commercial spaces where they have a lot of elevators, elevator lobbies, higher end spaces, you may find yourself having to specify what finishes actually go into the elevator cab itself, okay? So just be aware that while these are usually hands-off and they're usually just predefined by the manufacturer, there may be some customization if the budget permits, okay? Other types of elevators, so you may also run into wheelchair lifts, and the design and installation requirements of these are regulated by elevator codes, just like the elevators are. These can be installed on most stairs, and they can provide accessibility in spaces where traditional elevators are not an option. So here you can see is a example of a platform wheelchair lift, and right here is the platform, and this will just fold down, and you can roll a wheelchair on it, and then it will just move vertically up the stairs. And these are good, like this says, in spaces where maybe putting an elevator in just would not be practical, or maybe the budget wouldn't allow for an elevator. So this is an alternate way to meet the accessibility requirements for the space, is by installing one of these lifts. Also for retrofitting applications, if a building has to come up to code and they didn't originally have like an elevator in it, this is a way that they can meet that requirement, is just by putting a new platform lift into an old stairway. There's also, actually this should just say chair lifts, but a chair lift is similar to a wheelchair lift, but instead of a platform, it's going to have a chair that the person sits on, okay? And this is common for residential applications, just people who maybe are older and they can't get up and down the stairs anymore. They will have these installed, and then this will allow them to get up and down the steps. All right, so elevator systems. Ignore this first bullet point. Buildings under 15 stories usually have single zone elevator systems. And single zone elevator systems are elevators that are located in a single area of the building. All right, so it's just only concentrated in one area. If you think back to service cores, there's just going to be a single service core that has the elevators within them. Buildings over 20 stories usually have a multi-zone elevator system. So this is when you have elevators that are located in multiple areas throughout the building. Okay. Any buildings between 16 and 19 stories, they have the option of having either type. So it can just be located only in one area, or they can have them spread out throughout the building in multiple zones. All right, next we're going to talk about escalators. And escalators are power-driven stairways consisting of steps that are attached to a continuous circular belt. These move people vertically faster than elevators. They do not require emergency power because in the event of a power outage or emergency, you can't actually be trapped on these just because they function like regular stairs. So if they stop moving, you can easily just walk up or down them to get off of them. And they require adequate floor space at the loading and discharge points. All right, so at the top and the bottom of the escalator, you have to have sufficient amount of floor space so that plenty of people can get on without crowding one another, and then they can also get off without there just being a huge crowd of people or a pile of people at the top. So here are your basic parts of an escalator. These are very similar to just regular stair parts, okay? So we have our trusses, which is sort of like our stringers for our stair. And then we have our balustrade, all right? So this is usually just made of glass. So if you look at this one right here, this glass panel would be our balustrade. The moving handrail, so that's this black part, and that handrail is going to be moving as you're holding on to it. Then we have the newel at the bottom, which is just like a newel post on a regular set of steps. And then we have our landing at the top and the bottom. The most common arrangement for escalators is the crisscross arrangement. This arrangement takes up the least amount of floor space and it has the least structural requirements. So here's a diagram of what a spiral crisscross escalator will look like. Basically, the up and down escalators are opposite of one another and they're sort of like overlapping. All right, so we're going to be going up this way and then up this way. Then we want to get down. We're going to walk around and then go down and go down. So you have one set that's dedicated to just going up and one set that's dedicated to just going down. Another common escalator arrangement is the parallel arrangement. So parallel escalators face the same direction and are less efficient, more expensive, and they take up more floor space than a crisscross arrangement. So in this case, anytime you want to go up, as you can see, you have to go up and then you have to walk all the way around and then you have to go up on the next one for however many stories that is, okay? If you compare it with the crisscross, you're just going up and then you're just making like a 90-degree turn once you get to the platform or the landing at the top, and then you're going up again. So you don't have to go all the way around, right? You're just going up, up. So these are less practical, they're more expensive, they take up more space, so usually you're not going to see these implemented quite as much as the crisscross. And then this is our final slide for the lecture. So moving walks and moving ramps. These are power-driven, continuously moving surfaces similar to a conveyor belt that are used for carrying pedestrians horizontally or along low inclines. They are very similar in construction to elevators. They're available in a variety of widths based on the particular application that you're using them for, and you're going to commonly see these in airports, okay? So if you can think to like the terminal when you're getting off and you just grabbed your bags and you're trying to go to your car. Usually there will be some sort of a moving walk there. I believe they also refer to these as people movers, but basically you can get on them and they're always moving. So as you're standing on them, you can walk on them and you can basically get from one point to another in the airport a lot faster. This is especially useful like if you're running late for a flight or something. It'll help to speed you up a little bit. All right, so that's going to do it for this chapter. Like I said, that was going to be our final lecture for the course. All right, so make sure you read through the chapter. The chapter goes a lot more in depth on these topics. You don't need to worry too much about the technical aspects of it. Really focus in on the topics that I've included in this presentation here. But make sure you understand that, and if there's anything you don't get and you need some help, feel free to email me and I will get back to you.